All right, now we're going to talk more about ionic compounds and how the total charges must be canceled out or equal 0. And first we're going to do two terms. When you see the charge that's written above the element, that is called a superscript. Just think Superman flies above the city. A superscript tells the charge of the atom or ion. Okay? And the number that's written below the element is called a subscript. Subways travel below the city. Okay, so just think that. Subscript below the element, superscript is written above the element. Okay, and that tells the number of atoms of that element. Okay, so you're going to see that when we're making compounds. So the first thing I want you to look at is what if I have something like lithium, which is a +1, and fluorine, which is a -1. Okay, now, if you look, if I'm +1 and I'm -1, all right, do those cancel out? Yes, right? I have one positive charge, I have one negative charge, all right? So I only need one lithium and one fluorine together. And I don't have to write the 1 when I write the formula. If I don't have a number here, it's an understood 1. So it would be LIF. Okay, that's how I would make the compound, LIF. Now, that is a simple 1-to-1 ratio. And it's obviously easy because you can see, okay, you know, a +1 and a -1 would cancel each other out. Now, it's important to understand that there's two sides of every compound. There's a positive side and a negative side. The positive side is always the metal side. The negative side is always the non-metal side. Okay? So that's, you're always going to have the metal on the left and the non-metal on the right. So, what if I have something like this? What if I have magnesium and chlorine? Magnesium is a +2 charge. Chlorine is a -1 charge. So, I need to know how many -1s do I need to cancel out 1 + 2? One element that has a +2 charge. All right? So what do you think? I need 2 atoms of chlorine. That gives me 2 -1s, which gives me a total of -2, to cancel out 1 atom of magnesium, right? Because doesn't -2 and +2 cancel out? So when I write it, it's going to be MgCl2, which is 1 atom of magnesium, 2 atoms of chlorine. So you say, well, how do you, I mean, that, you know, is there a simpler way to do it than writing the pluses and the minuses over here? Yes, there is. Okay, it's called the crisscross method. So what you're going to see is, if I have something like this, if I have like beryllium, and it's a +2, and I have something like nitrogen, and that's a -3, okay, there's two ways to do it. You can say, okay, how many +2s do I, or first of all, how can I cancel out 2 and 3? You have to find the lowest common denominator because they don't go into each other, right? It's not like 1 and 2 and 2 and 4 or something like that. So what is the lowest common denominator? That is the lowest number that both of these numbers go into. Well, do they both go into 2? No. Do they both go into 3? No. Do they both go into 4? No. Do they both go into 5? No. Do they both go into 6? Yes. Okay, so what times -3 is going to give me -6? What times -3 will give me -6? 2. What times +2 will give me +6? 3. So 3 times +2 gives me +6. 2 times -3 gives me -6. They cancel each other out, right? +6 and -6. So I want you to think the total charges, total charge of each side, you can multiply, to find that, you can multiply the subscript times the superscript to get the total charge of that side. So let me do one more here. If I have titanium and it's a +4, and then I have, let's go with phosphorus, and that's a -3, what is the lowest common denominator going to be for this? 4 and 3. Do they both go into 4? No. 5? No. 6? No. 7, no. 8, no. 9, no. 10, no. 11, no. Up, 12. They're both going to 12? Yes. So what times minus 3 gives me minus 12? 4. What times plus 4 gives me plus 12? 3. So that would be written TI3 P4. All right? Now, if you don't like to do it that way, you can use what's called the crisscross method. All right? The crisscross method, I can take the number over here, not the charge, just the number, and put it there. The number here and put it there. Reduce them if possible. Otherwise, that's your best, lowest common denominator. All right, so let's do one of those. And this is called the crisscross method. All right, so let's go with sodium, which is a +1, and phosphorus, which is a -3. Right? So if I'm doing the crisscross method, what do? I take this 3. I don't take -3. I just take the 3 and I put it here. Then I take the 1 and I put it here. Okay, can I reduce 1 and 3? No. So it's just written Na3P. Remember, I don't need the 1 there because it's an understood 1. You see how easy that is? And that will give you your lowest common denominator. You can check yourself by taking 1 times -3 gives me what? -3. 3 times +1 gives me what? +3. Do they cancel out? Yes. So by taking the subscript times the superscript, you get the total charge of that side, if it's the negative side or the positive side of the compound. All right, so let's do another one, a little bit harder one here. What if I have manganese +5 and oxygen -2? How would I do that? Take the 2 and do what? Put it there, right? Criss it and cross it. Put the 5 there. Can I reduce 2 and 5? No. Okay, so can I check myself? So if I write it correctly, it's Mn2O5. But let me check it. 5 times -2 gives me what? -10. 2 times +5 gives me what? +10. Do they cancel out? Yes, so it's correct. I'll teach you how to name them later, but that's just, we're learning how to write them first. All right, so that's called the crisscross method. All right, I'm going to give you one more because you do have to reduce it if you can. So what if I have titanium, which is a +4, and sulfur that is a -2? So how do I crisscross it? Do what? Take this 2 and put it here. Remember, everybody pay attention, do not take -2 and put it there. You just take the number, not the charge. So just the 2 and put it there. Just the 4 and put it there. Now, can I reduce 2 and 4? Yes, to what? 1 and 2. So it's going to be TIS2. All right? And can I check it? 2 times -2 gives me what? -4. 1 times +4 gives me what? +4. So that's how you check it. So the good thing is you know if you did it right or not because you can always go back and check it. All right? So that's how we write compounds.